All right, so problem 3.17. Yeah, so it's telling us there's often a need to produce more than one voltage using a voltage divider. For example, the memory components of many personal computers require voltages of negative 12 volts, 5 volts, and positive 12 volts, all respect with a common reference terminal. So it's telling us to select R1, R2, and R3. So our common reference terminal is usually to 0 volts, right? So it's telling us the total power supplied by the divider circuit of the 24 volts source is 80 watts. Okay, so I'm gonna go ahead and just label these nodes, right? I'm gonna call this bottom node negative 12. I'm gonna call this 5 volts, and then this node right here, oops, 12 volts. We know that positive, negative, voltage across 12 minus negative 12, 24, right? Okay, so it tells us that the total, right, so total power supplied is 80 watts. So we know the formula for power is I times V equals V squared divided by R, or I squared times R. So this equation right here would be the most appropriate to use since we know the wattage and we know the voltage. So then we can say this would be the total resistance of the circuit, would be 24 squared divided by 80, which is 7.2 ohms. Okay. So yeah. So now it's telling us to find the value for each one. So off this value here, we could get the circuit. I mean, we can get the current, but we can also just use Ohm's law to get the current, right? V equals IR. Just say current is equal to V over R. We have both, so 24 over 7.2 should be 3.33333. Yeah, so this would be our current going across these. So I'm going to call this I1. Make it a lowercase I. Right, so then we can just go ahead and calculate the values for each with the EFC. So we know that I1 is equal to 12 minus 5 over R1. We already know the value for I1, it's 3.333, right? So then go ahead and say I1 equals, sorry, R1 equals 7 over 3.3333, which would be 2.1 ohms. Okay, I'm gonna go ahead and let's see, I'm gonna make more space. Okay, same. I'm gonna draw it in another color. I'm just gonna say this was 1, 2. This is R2, right? So same thing for R2. You know, sorry, make this legible. 3.33 equals 5 minus 0 over R2. So then it would be 5 over 3.33333. 5 over 3. That would be 1.5. ohms. And then I'm just going to switch this up, third part, R3. So then R3 is 3.33 would be equal to 0 minus -12, so 12, right? R2 is equal to 12 divided by 3.333, which would be 3.6 ohms. So we got 2.1 ohms for R1. R2 is 1.5 ohms. And sorry, this was R3. Oops. And our R3 is 3.6 ohms. And that should be the answer.